Well, welcome everyone. My name is Olivia Hereford and I'm a Regional Director for ICT Digital Media for the Bay Area Community College Consortium. And we're kicking off a first in a series of tech talks. We're going to be looking at doing at least 2 of them a month. And today we're very honored to have Sergio Nevarez, who is a senior InfoSec engineer at FireEye. And he is going to talk about red teaming and share some examples and do a demo if the demo demons don't get in the way. And then we'll hopefully have about 10-15 minutes left for Q&A. And so if you have any questions for Sergio, please put them in the Q&A. While he's talking, I will review those and see if there's anything relative that we might want to ask him right away. Otherwise, we'll walk through them together at the end of the demo. And then at the end, before we take off, I'll tell you a little bit more about what we're going to do with this talk. We're going to be recording them, and I'll share with you where you can find them, as well as where you can find more about the schedule of what's coming up. Okay. All right, so Sergio, I'm going to stop sharing and allow you to share your screen.
While he's bringing that up, I did the last talk. We have several coming.
I'm sorry. Yeah, I should introduce. I should introduce you, Steve, since you were our original tech talk. We weren't calling them then, but it gave us the idea to continue.
Right.
That. So I'd like to introduce Steve Booth, who is Senior Vice President and Chief Security Officer at FireEye.
So we have several of these queued up. We already have them calendared through the end of the year. We're going to go back and forth between sort of more technical and less technical, just because the audience is different, right? We have one queued up on the program manager side of things. One of them is a woman. There's going to be 2 people in that one. The woman that runs my internal program for how we remediate security problems here, paired up with a woman who was in charge of the program that does product security at Qualcomm. We have a pair of people coming in to do sort of a government style job. One of them is cyber policy at the OMB, and the other person does counter intel for the FBI. I have a CISO for January. I have probably 8 or 9 people queued up for these things, so that's good. And honestly, if you come up with ideas that you would like me to try to find people for, we will. We'll find what we can do. The thing with Sergio, and I'm going to say this one before he starts because this is important. Sergio actually has done some differentiating level work for the company that I'm working for. And I say that one because we have some of the best red teamers on the planet. We literally get hired by agencies to go do these things. And Sergio personally made more than half of our red teaming group better because of his cloud knowledge. So I would actually say that you guys can ask him big, ugly, hairy questions. The only thing that we might have to do is some of them will be such long answers, we might have to take them offline. Ask the questions in line. Just go ahead and slap them in there so we can have them as they come up. If there's any that are pretty interesting, like in context, because I know the order Sergio is going to be talking in, I'll come off mute and I'll do those there. But please ask the questions in line, and then we'll try to hit them all towards the end. All right, Sergio, you're up and you're on mute.
All right, thank you, Steve. I'll share my screen a little bit later in the example section and for the demo. First, I'll start just by talking a little bit about red teaming. So good evening, everyone. I'm very happy to have the opportunity to speak to you tonight about red teaming. So to start, I want to tell you what to expect from this session for the next hour or so. So first, I'm going to share with you some thoughts about the role and value of red teaming. I'm also going to talk to you about the skills that you can develop and some ideas to help you get started if this is something that you find interesting. Then we're going to have a technical segment where I'm going to show you a brief demo of a couple of persistence techniques that I've used in the past. I adapted the techniques to demo environments, so we'll see how that goes. Finally, as it's been said already, so there's going to please post your questions. Also, I want to encourage everyone, if you feel comfortable, to turn on your camera. It's better to speak to people than to this empty screen. So anyway, so getting started. So when you get into the cybersecurity field, you quickly hear that red teamers break into things and blue teamers are the defenders. So tonight I want to make the case for you to think about red teaming as more than breaking into things. And so why do I think this is important? So first, because the way you frame something will definitely going to influence the way you approach how you learn that. Second, I also strongly believe that you will become more effective and provide more value as a red teamer if you kind of expand your view of red teaming and not just get stuck in this view of, well, it's just all about breaking stuff and breaking into things. So if red teaming is more than breaking into stuff, so what are the other elements? So I think that at its core, red teaming is about security validation. And it's a form of security validation that requires you to approach a scenario, a situation, a problem from the perspective of an adversary. So from what I just said, two key concepts stand out. So one, security validation, and two, adversary. So keep those in mind. So think about these two elements as the why and the how of red teaming. So security validation can help you answer the question, why should we do red teaming and what value it can provide? And thinking about the perspective of an adversary can tell you a little bit about how you approach red teaming. So first, let's talk about security validation for a bit. So if we see it as a form of security validation, so what do we need to do to be able to validate something? Well, the obvious first step is you need to know how it works. If you don't know how something works, it's not possible for you to kind of validate it effectively, right? So you need to know how it works. You need to know how it is expected to behave, what the underlying assumptions are and when you think about these things, don't just focus on the technology and the tools and the system administration or software behind that. So think about people, business processes too. So consider their goals, how they work, how they're measured. Doing so will not only give you more options to achieve your red teaming goals, but also enable you to improve the business as a side effect. So the other important element that I talked about is the perspective of an adversary. So how do we do this? So first, keep in mind that often advanced adversaries look like normal engineers on the network or on the host. So if there's only one point that you take out of this topic, just keep that in mind. So more often than not, like advanced adversaries do the same type of stuff that your normal IT professionals will do on your network. So a while ago, I heard on a security podcast that a sophisticated attacker is indistinguishable from a competent system administrator. I apologize because I don't remember which podcast it was. It was a long time ago, so I can't give proper credit, but think about that. So this means that an important skill set includes learning the same type of things that makes a competent system administrator, or I would say a competent engineer in general. It can be network engineer, software developer, whatever the field or the subfield is. So things like understanding operating systems, scripting, automation, anything that would help you scale your work. Also learn about cloud services, especially now that everything and so many companies are moving to the cloud, and how you can use code to deploy it and maintain infrastructure. Study network protocols that are widely used on the internet. And by the way, one way to do this, if you're kind of a nerd like that, just find the internet standards and the RFCs and just read that and think about how you can use those in ways that maybe they were not intended. So besides doing stuff that normal engineers do, I think it's also important to practice approaching problems from a security mindset. And this could be a whole section of its own. And on this point, in the resources section, the slides that I'm going to share, I have a couple of blog posts that I highly recommend that you read. I just as a kind of a preview of one of those is a blog post by Bruce Schneier. Probably a lot of you have heard about him. And in his post, he talks about security mindset and how kind of one example that he gives is how he's talking about this, some kind of product that it's some invisible way of tagging kind of your belongings to kind of prove that you own them, right? And so he says something like, well, a good way to use this would be to tag your belongings, and then that way you prove you own. A better way to do it would be I tag your belongings and then I call the police. And so that's kind of a short example that shows how something that somebody marketed for a specific use, somebody with a security mindset can see it in a completely different way. And so anyway, so I also recommend that you become familiar with the MITRE ATT&CK framework and threat modeling. If you're not already familiar with those topics, those are very important, very useful when you think about how to approach a problem from the red teaming's perspective. Also, just as important, understand the security principles like least privilege, defense in depth, and apply them to as you learn about those normal things that engineers do that I was talking about. So now, given that learning and practice are essential to becoming a good red teamer, I also highly recommend a book that I recently read, and it's one of the best books that I've read this year. It's called How to Take Smart Notes. And I could speak about that for an entire session, but it's not on topic. So I'll just highly recommend that. It's about learning in general. And you can benefit a lot for security and any other field as well. But for right now, I'll just recommend that you read it, build a lab, a secure lab, and then pick tactics and techniques from the MITRE ATT&CK framework and practice the concepts from those books in your secure lab. So by the way, building a secure lab could also be actually a series of sessions on its own. So if you're interested in that, please share feedback about the type of sessions that you would like to see, as Steve was saying, and we could potentially have sessions about building a lab in the cloud or on your host, and the type of things that you could do to test and learn with hands-on experience. So before jumping to the examples and demo, let's talk about the benefits about red teaming a little bit. So I talked about challenging underlying assumptions a little bit earlier when I was talking about learning how things work. So by doing that, you can identify strengths and weaknesses and highlight the strengths as ways that teams can use to improve or areas that show weakness. So for any science nerds in the audience, you can think about this process of challenging assumption as part of designing an experiment. And so in that way, your kind of null hypothesis would be something like there's no effect between attack A and security control C. Then come up with ways to falsify that hypothesis, and whether you prove that's the case. If you manage to prove that's the case, then you've found a good strength to highlight for the team. And if you falsify that claim, then you have a good set of findings that you can use to make security recommendations. So when you keep the business context in mind, you can also help prioritize those remediations and provide a team with a better understanding of overall risk. Like, so not all findings are going to have the same impact on a business. So red teaming is also an effective way to identify attack vectors that were previously unknown. And so think about these benefits. And just like I was saying, so if you focus on learning the kind of normal things that engineers do, and then apply the security mindset on top of that, by the time you finish with a red team, you're also in a position to help provide recommendations to the business on how to improve some of those processes, right? Because if you're learning the same skills, there's ways that sometimes improving the security doesn't have to conflict with the operations, and sometimes you can do both. And by setting guardrails in place, you can allow business process to move even faster.
Hey, Sergio.
Yep.
I just had somebody send me a question on the part about doing the testing in the business context. Can you explain that a little bit more? Like how to not be doing like finding a theoretical, look, you didn't patch something, versus this is your crown jewel and here's how I broke into it. Can you just sort of expand on that for a second?
Yes, definitely. So, I mean, any business is going to have its own set of assets that are kind of highly valued by the business, and you may have a really cool vulnerability or good attack that you found, but maybe it doesn't get you anywhere near close any of the kind of proprietary information that the company really values. Maybe all you're able to do is access a kind of segmented part of the network that doesn't have any kind of business kind of value for. So by understanding what the company does as a business and how they make money, how they get revenue, and kind of tying your findings to the impact that a potential attack using the attack vector that you found can have on that business, you can help the business prioritize the risk. Because it's not rare for security professionals to find a really long list of vulnerabilities, right? So if you just dump a list of hundreds of vulnerabilities or issues that you found, and you just leave, like, that really doesn't provide the business with a lot of value, because it's, I mean, next year, whenever you do that again, probably they're going to end up in the same situation, or they're going to end up remediating stuff that maybe was not as important based on the business context. So I don't know if, does that answer the question?
Yeah, I mean, ultimately, you're proving that you can get to something that they care about, not proving that you can do some theoretical different, like sort of the difference between pen test and red team, right?
Right. And putting the security controls that they have in place in context, right? So maybe you're able to bypass the security control, but there's 5 more that will stop you, right? And so you don't have to necessarily make a big deal out of one if
Right.
with the context. So all right, so let's talk about the example. So this year in the latest M-Trends report, so there was a section about cloud, and they described how attackers, once they obtain credentials to the infrastructure, they rely on the same tools that organizations use to run their business. And I thought it was kind of very relevant to the point that I'm trying to make, that often attackers do the same normal things. So to that, let me share my screen. Are you able to see something now, or I don't know what I'm...
Yeah, it just came up.
Okay. So let's talk about a normal kind of a hypothetical scenario for this diagram that I have. I was just imagining some kind of IT onboarding process in the cloud where you have this an IAM action. For those not familiar with AWS terminology, IAM is the identity kind of provider in AWS where you control your users and roles. Then you can have a CloudWatch rule to trigger kind of a Lambda function, which is like code that you write to execute something. And so by doing that, an IT group could automate the process of, maybe once they create a specific account, there's another set of business-related processes that have to take place, right? So here I represented that with an API that maybe the team has. So this would be a pretty normal kind of way to automate a certain process in the cloud. So now, if you take the points that I was talking about a little bit earlier, and now how could we do something like this, but use it for kind of a nefarious purpose? So now we have the next slide, which is, if you see the diagram, it looks exactly the same. The only difference is the scenario. Instead of saying IT onboarding, I envisioned this idea I got from Rhino Security Labs, a great resource. I highly recommend that you read their technical blog if you're familiar. So they develop a tool, and one of their modules kind of backdoors new user accounts. So I kind of tied that with this IT example that I was talking about, and you see the exact same elements are part of that. It's just that instead of kicking off an IT process, here you're essentially writing code to backdoor any new account that gets created. And I'm going to show that in the console in a few minutes. Now, the second one, now let's imagine company X, and they develop some kind of product, and they have a product API for customers to interact with their software. So now you could have this an AWS account where you have some kind of workload for the API to provide the services. And then you have an account where you have the API hosted, and users authenticate with an identity provider, make an API calls. And this would be kind of in the back end what the API would do to assume a role in the target account and just provide whatever business service they provide. Now, this is again, normal business process that maybe a software engineering group would come up with. Now, this actual workflow, but for a different purpose, I used on a red team some time ago, where we were looking at ways to create backdoors in an account that we had already compromised. So we were concerned that the access that we already had maybe could be lost, and somebody would find the accounts, the access keys that we had created, and they would deactivate, right? So what we did is we essentially created a backdoor in a specific target role that we had already compromised, modified his trust policy document, and then I created an API on top of that that looks exactly like the one that I described in the previous slide. But the only difference is that instead of providing some kind of service for a product, it's returning fresh API keys for the target account on demand. So that means whenever I want to access the account, if my other accounts got disabled, I could just call an API that I stood up and get temporary keys. And if those if they catch those, get more later, right? Unless they actually detect the whole workflow that was stood up. So now let's do a little bit of the demo. So hopefully everything works. So I first to set the stage for context for these kind of components that I laid down in the diagrams. There's some kind of users and roles that I create in advance that so for example here, roles for the Lambda functions that I'm going to show. So even though I skipped that for just to speed up the demo, if you're not familiar with Terraform, and another thing that I highly recommend that you Google and learn about. So this is the Terraform file that I used to kind of do that those prerequisites, and just a bunch of resources that I created in advance to create those roles, and that I'm going to use so that we can focus on the more interesting portion here. So with that, let's see. For the first one, we talk about how when you can use CloudWatch rules to automate the process of backdooring a user. And so the interesting thing about this is that because of the services that AWS provides, you can not only backdoor users that are already part of the account, but you could create an automation workflow that backdoors any future account that's going to be created at any point. So this is what I'm going to show here. So here's a CloudWatch rule that shows, so this one is already created and it launches a Lambda function, but let's go through the process so that you can see how that looks. So what this does is that you specify a type of event, in an API CloudTrail event that you want to use as a trigger. So here, for example, you can say, I want to use an IAM event, and let's do an API call via CloudTrail. So in this case, I'm interested in the create user API call. So once we do that, then so this is what the event pattern looks like. And once that's in place, all you have to do is specify a target. So I already have the demo backdoor Lambda function here. I'm going to show that the code to you in a second. Here we just specify the target, and then like live demo, and let's not enable it because I already have the other one enabled. So that's it. That's all you have to do as in this case, as an attacker to set that up. And obviously right now I'm showing this in the console for clarity so that you can see the process. But just like I showed the Terraform code for the users and the roles, the boring part that I created in advance, this in practice in a red team engagement is done either via code with something like Terraform, or using the AWS API, the AWS command line utility. Very useful for red teaming. So now that that's done, let's before talking about the other demo, let's create a user, because sometimes CloudTrail events can take a while to propagate or to get received. So and while I do that, I see a question here. Is Terraform separate cloud provider? No, so Terraform is so it's not part of AWS. It's the company that builds that is called HashiCorp. So if you look at it's the Terraform by HashiCorp. So it's essentially just a way for you to use code to deploy your infrastructure.
That concept of infrastructure as code is incredibly important in the cloud. So like You're not buying computers and plugging them in and building operating systems on them. You're literally just modifying lines of code and building the infrastructure in cloud that way. Just a different way of thinking.
So let's create a user right now. And because I don't want anything to go wrong with the live demo, let's deny everything so that the keys cannot actually be used. So we have the user here, and it's probably going to take a while to get, but let's see if, oh, actually, so live demo, you see, like I created just the console, and security credentials were just created right now. So let me show you how that happened. So if you go here to CloudWatch, you can see your logs, and you can see your demo backdoor, and you can see there's a new event just from now. And this is the code, I mean, the output from that Lambda function. So this is just what happened here with creating backdoor for this user. And this is the key, and this is the secret. And this is a demo issue, probably there's another step where I was calling an API to as a listener so that part is failing. I'll take a look.
Before you change off that tab, explain in plain English what you just did.
Yeah, so essentially,
what's the result of the action that you just created?
The result is that now, let's say in this case, an IT professional created this live demo user account for maybe a new employee that was onboarded. And now as an attacker, because you added that automation with CloudWatch, with a CloudWatch rule, now you have a set of access keys that give you access to that new account that was just created. So within seconds of the account that being created, the attacker already has access to that account, right? So this tells you a little bit about the impact of how you can use these cloud services for offense as well, because it's not just keys that you had already compromised before, but accounts that don't even exist when you work on this.
I think of that in terms of imagine what happens when you have you're in the operations center and you have your oh shit moment and you tell everybody to go change all their passwords, or you even say, you know what, I'm going to nuke those accounts and I'm going to create new user accounts, and it wouldn't matter. It wouldn't matter at all, right? That's the difference between
exactly.
a pen test that says, hey, you missed a patch, versus he just established persistence so that no matter what you're doing at this point, he's going to be able to in your new accounts that don't exist yet.
Right. So, and let me show you what that code looks like. So this is the Lambda function that does that. So it essentially takes the username from I can't highlight when I'm sharing apparently. Oh, there we go. So there's the username that I obtained from the CloudTrail event that is passed to the Lambda function. Then I just print something so that that's the output that we saw. And then we use so AWS has an SDK for Python to interact with the API, which is Bodo 3 for anyone who's done any AWS related programming. So you have, we're using that library, that SDK, to create a set of access keys for that new user that was just created. Then we just obtain the access key ID, the secret, and then I'm posting the results to a listener. So in a kind of normal kind of network red team or pentest, you would have whether it's your Netcat listener or a web server or some other kind of ways for you to receive data that you want to exfiltrate out of the customer. In this case, because it's a cloud related demo, I wanted to show how you can do the same with cloud services. In this case, without having to deploy any server, I can just use a Lambda function and an API gateway to act as a listener.
We had a question in the thing, and you're going to explain this better than I did. Somebody's asking like, what does a Lambda function mean? And the way that I'm explaining it is they're like little autonomous pieces of code that you can submit off into Amazon, where you're sort of buying it per CPU cycle, right? There's no server, there's no operating system. You're saying, go compute this and come back. But in this case, it was go compute the automation that I just built to establish my persistence. But like Lambda functions are all over the place. Like,
yeah,
Uber runs in Amazon, and Netflix runs in Amazon, and there are thousands of little tiny Lambda automations everywhere. Now, Sergio, in your words, explain the same thing.
Yeah, exactly. So it's, I mean, I think you did a good job with the explanation. So like, so in short, it's just so the way AWS markets that is kind of like a serverless kind of functions for you to kind of write your code, right? So before Lambda existed, what you would do is still in the cloud, you could deploy something like an EC2 instance, which is like their service for you to deploy VMs, virtual machines in the cloud. And then let's say that you have a Python script like this that you want to run in the cloud. So before Lambda existed, you would have had to create a virtual machine, then install Python, install all the libraries that you need for whatever like program or script that you want to run, and maintain it, update it, patch it, or run the risk of the same security problems that exist everywhere else, right? So with Lambda, essentially Amazon runs those servers, and all you have to do is upload your code. And they support a lot more than Python. So they have Python, they have Node.js, they have Go. So they have a bunch of different runtimes that you can use to basically write your code in any language that you're familiar with or feel comfortable. So kind of that's the way I would summarize it. Let's see, any other question?
No, that was good. I'm just trying to pick out there's a chunk of really good questions in the chat, but they're bigger, so we'll hold those for later. I'm
Okay.
trying to do the ones that are kind of autonomous that we can do in the middle here.
Sounds good. So now let's talk a little bit about that listener that I was describing. So this case, I created this listener. This is a very simple kind of trivial version of a listener where all I'm doing is printing the whatever you receive, right? So this is as simple as it gets. And what you can, so essentially here, if you post any data to this function, it's going to print it out. So what we can do then is essentially what I did for this workflow. I created an API gateway. So this is another Amazon service that you can use to run serverless related workloads. So you can essentially build an API in the cloud, and then the backend of your API would be Lambda functions. So again, you don't have to run any servers. And then those Lambda functions, if you have a more complex application, you can run a database to maybe get data out of your database. And by the way, you can also do that for red teaming, right? So I'm showing a very simplified version, but let's say that you wanted to scale, you're compromising a really large environment with thousands of hosts, and you want to keep track of everything that you've been compromising, and access keys, secrets, etc. You could run your Lambda functions and then put a DynamoDB database on the backend and start kind of putting all the secrets that you're collecting from the environment without having to run any server at all. And another advantage of running this in the cloud is that if you host your infrastructure for red teaming somewhere else, and then the SOC or the blue team of the environment that you're testing catches you, they can just block that pretty quickly, right? If you do that with serverless services in AWS, they block that. I mean, it's pretty hard because unless they want to block all the AWS IPs, it gets more difficult, right? I mean, there's definitely ways to mitigate some of these things, but it gets more complex than just blocking an IP. So anyway, here I have the listener. So the listener, what it does is that it essentially on the back end, well, let me show. So here, this essentially acts as a proxy for that Lambda function, right? So here you have a request. So it supports a post request. And then you proxy that request to the Lambda function, and the Lambda function just prints that output. So let me see. I have here hopefully this works. So let's see, demo variable. So this is the listener, the API. And as you can see, it just prints back that. So that's kind of like how I'm using this as a listener for that backdoor workflow that I just showed you. So when the account gets created, the keys get created by that automation that I showed, and then they get posted to this attacker controlled listener. Now, the other interesting one here is the get keys one that I showed you in this diagram. So this one here. So again, the API that I'm showing on the console, it's this part here. Then there's the Lambda function that acts as a backend. And in this case, we have a target role. So let me show so these are the kind of the pieces that I mentioned that I created in advance. So one of these roles, it's a target role, and I'm denying all because I don't want those keys to be used for anything. But this is the role that this function is going to target. So what it does is get target keys. Just like the other one that I showed, again, I'm using the Boto3 SDK. In this case, I'm using a different service, which is STS. This is for those not familiar, it's a service that AWS provides to create temporary credentials to services. So instead of having permanent access keys, you create time-based keys that you can configure how long you want them to be used for. And this acts as the basis for the assumed role operation, which it's IAM users kind of taking a temporary role for a role with different set of permissions on a temporary basis. So here I'm kind of targeting that role, and then just naming the session. And again, just getting the access keys and a secret session token. That's part of because it's a temporary set of credentials, and then returning that. And then again, tying that to the API.
Stay here. So don't go off here for a second. Again, plain English, tell us what this little piece of code does. What this piece of code does is you have a target role. Think about that. It could be your admin role in the target account, which in fact it was how we used it in that red team where I was talking about how we used this workflow. So we had you just hired a brand new SRE engineer to go work inside your cloud environment, and you assign him this role. Right.
Yeah, so this could be a legitimate role that they have that admin role. So with the access that we had already obtained with that role, we modified that role to be able to trust this piece of code that I wrote here, right? So you have to establish that relationship, and that is done by in IAM. So let me show you. Here's the target role, and every role has a trust what Amazon calls a trust relationship. So here, what I did is establish a trust relationship with a Lambda role that I'm using for that function. So in plain English, this is just basically establishing that relationship between the target account and the attacker code. And once that's in place, then what it does is that on demand, whenever you want to assume that administrator role on the target, you just call this function and it returns a new set of keys that you can use to take that role and perform any action that account can do. So the way it looks when you call that, so again, well, first here in the API, here we have the get keys endpoint. And again, it proxies the request to Lambda, to this Lambda get target keys. And so I have that here. And if I issue a new request, hopefully it works. Yep. So you see, there we go. So here's the key ID, the secret, and the session token.
So now in Amazon, they do things a little differently in the way the roles and everything go. And this is not an Amazon class. I want to do one of those. I actually would love to do a sort of a crash course on AWS here. I've got a couple of people asking good questions though. So on the back window, the one you have there, which is console.aws.amazon.com, services and everything. Correct me if I'm wrong. That is, if you were to go sign up for a relatively cheap AWS account, you are just going to get this, right? This is default yes. AWS. You could go build your own Lambda functions from day one, right?
Yes. In fact, I created this this account earlier today because I didn't want to use my kind of the account that I use for real kind of where I practice and where I do my
Yeah.
own lab and that kind of stuff. So I create a brand new demo account just for this, and yeah, like so you get
Demo
when you
account
sign up.
Is free or cheap, or what are we talking about? Like,
so when you sign up, you have 12 months for free for the free tier that Amazon. So that essentially means you get free access to kind of the lowest tier of whatever services they have, right? So if you want to deploy a VM in the cloud, you can have the lowest tier of the kind of like the least powerful VMs that they support, right? So you could run that for the whole month for free. If you exceed the free tier, you have to pay is depending on how much you use, right? But for very cheap, you can have all of this that I'm showing for, and
right.
if it's a new account, for free.
Now, two parts off of that. The first one is that for anybody that was going to get a job, if you have any of functionality understanding inside here, and you can say like in the interview, I'm not saying I'm a Lambda expert, but I've created a few, right? And that's going to absolutely help you in an interview. That's number one. The second one is Sam asked a question on what's the defense against this attack. I'll give my plain English one, and then he'll give the more technical one. From my side, this is why the blue team is so hard, right? Because this is like when you get into the red team and you say, okay, we lost the credentials on a laptop, for example, and that goes down this chain of events inside an attack life cycle that results in just God mode in 18 hours, right? This is way less than 18 hours. So when really good blue teamers start to get like neurotic on micro segmentation of credentials and just layers upon layers of controls on here. Part of the reason why that things like the Terraform and the Ansible and the Dockers and the Kubernetes, they're all out there to be able to build all those tiny little pieces of functionality in, so that it's really hard to not do only what it's supposed to do. Like literally in Amazon, there aren't even default routes. You have to tell, okay, from my front end to talk to my back end, here's how the packets would route, right? It's that specific. The problem is a lot of people get lazy and they go in and they add in a bunch of things to make it act like a normal data center, and things like this would work everywhere, right? Now, Sergio, what sort of a defense would you have for an attack like this?
Yeah, so in this case, let me go back to the diagram just to show. So for this part here, if you think about this as an attacker account, then there's nothing you can do on this part here at the bottom to defend, right? Because this is attacker, right? Although actually in the red team that I was talking about, we actually, so the environment that we were testing had multiple AWS accounts. So we actually used one of the accounts that we compromised as the attacker kind of to launch more. So in that case, they could have detected that, but anyway, that's another point. So here, in this workflow, the only component that we touch on the victim side is the trust policy document of the target role, right? So there's a couple of things that I would say. So first, like obviously there has to be effort in prevention, right? So the kind of like good following the recommended practice by AWS and the well-architected framework in IAM, that really goes a long way to help you mitigate and reduce the likelihood that something will happen. But now in reality, like there's going to be mistakes somewhere, and you're likely going to lose like key somewhere. Somebody's going to leak credentials somewhere. So I would say you also have to think about the different layers of how you can prevent or detect something. So if you first you do everything you can to prevent that, and that's for that I would say, as I said, like the following the well-architected framework by AWS, that's a great start. But then on the defense side, just like I showed here, how you could use Cloud Watch rules for offense, you could do the same for defense, right? So you could, for example, actually let's do it right now. So we could do something like create event by service. Let's do IAM and then API. So we could do update. I forget so there's a specific API call which I don't remember if it's update trust policy or something like that. Let's see if it shows here right now. Events. So there's a specific event. I'm blanking out on the. Oh, there we go. This is the one. Update assume role policy. So this is the event that. So in that attack that I described, the attacker has to modify this trust relationship to be able to do what I just said, right? So, I mean, if in an environment, in a production environment, you have hundreds or thousands of roles and hundreds of users. If you're not it gets very difficult to monitor for changes like that, right? So, but if you are able to do the kind of security hygiene ahead of time, where you identify, so going back to what Steve was talking about earlier about the crown jewels of the business. So if you know which accounts are your crown jewels, which environments are more sensitive, which roles give you more access to specific things, you can identify those, maybe tag them, and then use a combination of those tags and CloudWatch rules to automate that. So in that way, so you could do something like this. And in this case, you have a trigger that says anytime there's an update assume role policy event, and you can narrow it down to update assume role policy for this specific set of, or if they're tagged by this. So I'm here just showing the workflow, right? And then here you have.
Hang on for just a second, because Sam, actually, I think you're doing a very good job, by the way, of linking this into sort of IT 1.0 thing. So CloudTrail as tripwire for the cloud, it's a little more than that. Think of it like in a world where you've got your whole data center in an Amazon. It's your networking logs, it's your logon events, it's your everything else, and yes, it's also somebody modified your cloud, right? So if you were to be wanting to look at, somebody attempt to log into from known evil space that one of the Russian nation state attack groups had used, that would also be in your CloudTrail logs, right? It's just, you have to think of it a little differently, because you're no longer in a world where you're waiting for some antivirus alert to go off, right? Because you custom built your cloud and you have to be able to define what's weird, right? Now, literally the very beginning of that could be as simple as somebody changed the way we do assume role, which, by the way, assume role happens all the time, right? Yeah. So it's not somebody assumed a role. That's all day, every day when you're human beings doing something, but they changed the way that functions. That's an investigation. Very much like I just had an aberrant log on to my Linux box in my old data center, right? I mean, like, you just have to change your thinking based on what's going on in there.
Yeah, no, yeah, that's a good point. And also, so everything that you do on the console or via the AWS command line utility gets logged in CloudTrail. Well, I should say most things. Not there's things that are not supported, but and there's a good set of interesting kind of techniques that focused around how you can do certain operations without kind of leaving a trail in CloudTrail, right? So I recently watched a very good talk from kind of the guy's name is like Nick Frechette. Like, I have the link in the resources section of the slides, and highly recommend that. And he found a way to enumerate permissions when you recover compromised keys without leaving a trail in CloudTrail, and it's really fascinating what he found, and so I recommend that you check that out. So let's see.
Sergio, we've got about 10 more minutes. Is there more you want to demo, or should we?
No, I mean, I think we can open it up for like just kind of open questions at this point. If there's anything else
I see one from early on from Sandy.
Yeah, it's a chunk of questions and they're good ones. So Sandeep had asked the thing, he said, what are the assumptions made to successfully establish persistence? Namely, are these private subnets or public facing subnets? Are there NACLs or security groups that explicitly accept or deny access? In addition, the temporary access keys are generated for users for assigned roles or long-term access. Now, I would say that this overall talk is red teaming, not only red teaming in the cloud, although we aimed it at the cloud. You can answer that thing however you want in there. And for simplicity, I will just copy and paste it, and so you'll see it in the bottom of your chat there, Sergio. There's a chunk of really good questions in there. That's why we held that one for later.
Yeah, I mean, assumptions made to successfully establish persistence. So I would say, specifically in the cloud, like, I mean, if you're looking for ways to establish persistence, I would say well, I would split it into two categories. So if the environment has a lot of virtual machines and so there's a lot of EC2 instances running, there may be situations where you have access to a specific account in IAM. You still need to gain your way into those EC2 instances. So that's one area that you need to kind of compromise if you want to establish persistence. But I would say, at least in kind of the work that I've done in the past, if you manage to compromise the IAM deployment of the environment, essentially you have a kind of free pass to do whatever you want, right? Because once you get admin access to the AWS account, you can create your own accounts, you can create your own roles, you can modify policies, you can. So I mean, there's a lot of techniques to get access to an EC2 instance, for example, if you have sufficient permissions. So I would say to establish persistence, the main requirement is, like in AWS specifically, would be just that if you compromise a specific set of keys, just think about how you're going to get that access back if those keys get disabled, or if the blue team kind of blocks that account because they found something suspicious. So it's just a matter of finding new kind of backdooring different accounts on IAM or creating services to get new access keys. So I kind of like feel like I'm rambling out, but the point is I would focus the efforts on IAM first if you want to establish persistence.
By the way, that's a repeated thing everywhere. So in a world where most people think, oh, I did my patching, I'm fine. That's just not true. We have worked, we've actually had some quarters where as many as 25% of the breaches that we work involve no malware at all, ever. My favorite is when they sent an email out to somebody from a Gmail address that said, hey, this is your IT department. We're checking to make sure everybody's passwords are strong enough. What's yours? And the human just hit reply, and it worked. And they got in and took that all the way down. And that, by the way, was a national bank in an Asian country. And you got like two-factor auth would have helped, right?
Yeah, and also one point that I wanted to make relates to the speed at which both the normal engineers and attackers can move, like when you use cloud services. So in the same engagement, so there was a specific data exfiltration portion that we did where we took gigabytes of data out of an S3 bucket on that environment. But instead of transferring out to a specific server that we owned or anything, we set up another account, another AWS account, another S3 bucket, and then we synchronized the content of the target with our own. And because it all happened in the AWS backend, we took out gigabytes of data in a matter of seconds. And the best part, without even leaving any trail of that, because if you want to log like specific events in S3 about the access, which files get access, more than just API calls to just kind of management calls, that's another kind of layer of logging that you need to enable. And often it's not, because it gets really expensive depending on how much data you have. So anyway, the point is that when in a normal environment, it can take an attacker a good amount of time to exfiltrate data. And there's a lot of points for the blue team to detect that and to stop, because they see a large volume of traffic going out. In the cloud, you take data out of S3 to another S3, your blue team is not going to see anything unless they're logging kind of all the data events.
That's part of the reason why it's sort of the cloud security jobs are exploding, right? Because if you were to try to exfiltrate it out of a data center, it's going to leave out your egress point, and you're going to have a bunch of network sensors in the way, and you're going to have, well, you don't have any of that, right? Because in the cloud, so to speak, your data center isn't even yours. Sergio, I just pasted another question from up above. Said, do you have any labs you'd recommend for testing hybrid environments, say connecting a home lab or server into cloud services like AWS or Azure? There was another question on roadmap for certification. So those ones are sort of interconnected.
Yeah, there's so for the first one, let me bring it up because I think I have it in the.
While he's pulling that up, everything that he showed you about how to do these sort of semi-evil things inside the cloud, they also, by the way, are exactly what you would do if you were building a system in the cloud, right?
Yes,
like
exactly.
All of it. There's no malware involved here. We're not talking any patches. These are all exactly what you would do as an engineer building your own system.
Yeah, exactly. And the same type of skills that you would need to know how to compromise IAM effectively and kind of establish persistence. And it's the same set of skills that can help your admins secure the environment, right? And not just secure it, but also automate and do things faster. So that's kind of what the point that I was making earlier about how when you do learn those normal things and on top of that you apply the security mindset, then at the end of the day, you can go back to the IT group and also help them with recommendations on how to kind of automate certain things and not just how to improve security. So anyway, related to the first question about labs, so this is a resource that I found some time ago, and I found it pretty interesting. So I don't know if kind of specifically what type of what areas interest you more in the cloud specifically, but this is kind of like a good general set of materials for, I think it covers both AWS and Azure. I looked at the AWS one, I haven't looked at the Azure one for this specific GitHub page, but that's one. For certifications, so are you talking about certifications for the cloud or certifications for
do certifications in general, like which ones are more useful versus less?
I mean, I kind of share the view that Steve shared a few weeks ago when he talked to you about how I don't necessarily think a lot of certifications are what makes the difference. So I think it's all a matter of what you're able to do, what skills you have, and not so much kind of having a long list of certifications. A lot of them are just kind of multiple choice questions that if you just memorize certain things, you pass them, and that doesn't necessarily prove that you have skills. Having said that, one, if you're interested in kind of offensive security, red teaming, so if you haven't heard about this set of certifications, so these, I would say they're pretty good. And the main difference between these ones and others that are kind of multiple choice is that in this case, it's just a matter of kind of hands-on stuff. So the actual, for example, this one, which is one of their popular kind of certifications, the test is they give you 24 hours to break into a network, and that's kind of the what you need to do, right? So it's not answer a test with a bunch of multiple choice questions, and so you actually have to prove that you're able to break into an environment and then write a report about it. So I would say in general, certifications that give you hands-on experience would be good. And I would say also certifications for the cloud, I think those would be beneficial as well, because getting familiar with so many different services, and those are constantly changing. So that gives you a good kind of baseline.
Yeah, I agree with that one. Even the certifications that don't seem like security ones, but they're about the cloud, like being, Amazon certified architects and that kind of stuff. All you got to do is just figure out how to think like a bad guy, and all of a sudden you take the exact same knowledge in a different direction.
And honestly, like I think in the end, as I said, it's a matter of what you're able to do. So if you're really interested in the cloud, look at the kind of material that is covered by the AWS Solutions Architect certification. You don't even need to take the test if you don't want. Like, just look at the content, learn it very well, and if you master those skills, whether you have the cert on paper or not, I mean, definitely a good thing to have if you did the work. But when you show up for an interview, kind of if you're able to show kind of that what lab you built, what kind of things you've tested and stuff like that, that's going to, I think, in my opinion, give you a better chance to make a good impression about your skills than if you just show a list of certifications and then not necessarily able to demonstrate.
All right. Another fast question. Only got like a minute left. You had mentioned a security blog, but your audio had fuzzed out at that point. What's the security blog that you said that was worth having them watch?
Security. So was that when I was talking about the security mindset, or?
Probably.
So here's maybe it was this one that I was talking about. So I'm going to share these slides. So it was either this one, or I was talking about the Rhino security technical blog. That was another one that I mentioned. And then I forgot to mention this one. So Cloud Code, it's a really good thing to look at if you are not familiar with that. So what Rhino Security did is they built a kind of vulnerable environment in AWS. So and it's all automated. So you can follow the instructions here, deploy it into your own account. So sign up for a free tier account, deploy this and follow these instructions to deploy that. And then kind of follow the different scenarios that they have and try to compromise and get access and do privilege escalation and all those things that are covered by this. So this is another great one to look
Now,
at.
as a bit of a wrap up here, there's a pretty big difference between penetration testing and red teaming, right? So pen testing is going to tell you when you missed a patch or something. Here's a couple of examples of actual red team success criteria that we've done. We had one which was, could we hand the red teaming people a standard corporate laptop with a standard new user account? And how long would it take for them to be able to be sending out email as my CEO, right? That's a red teaming success criteria. The one we're talking about, establishing persistence in the CI/CD pipelines, that's another one, right? You can think of them as the success criteria are usually the things that your non-technical execs can understand and get freaked out about, right? Because if you say, well, nobody should ever be able to get to my whatever the crown jewel is, you're like, okay, let's find out if I can do that one, right? Because if you can, now you know what the changes are. The purpose of this is to be able to cause changes in with the human beings and how you build your infrastructure in order to no longer make that possible, and then do a new red team to go figure out a new way in. All right, we will get you the slides. We will get you the list of resources. Sam, Olivia, is this what we were hoping for?
What we'll do is that we'll have the slides, we'll have the video and the chat file posted to BayICT.org probably by tomorrow. And BayICT.org has 2 pages that we're going to put this on. We're going to put it on both the faculty and the student page.
All right, we're going to try to do things like this of varying technical degrees every 2 weeks for the foreseeable few months.
Yeah.
So
The next talk is on November 17th, and that is Kippy Arcara and Jim Mavongo, and they're going to be talking about security program management.
Thank you. That was very good.
Great. So thank you so much for kicking this off with us, and hopefully we'll see you next week.
Thank you. And one before we leave, one thing I forgot to mention. So if anybody is interested in learning in depth any of these topics, whether it's want to know more about Terraform or the persistence mechanism that I talked about, feel free to find me on LinkedIn and reach out offline, and we can connect and talk about any of this later.
All right. Thanks, everyone.
Thank you.
Enjoy the rest of your evening.
Thank you, you too.
Goodbye.
Thank you.